Hi there, guys. Um, we are back again to passage 3 this time. It's going to be test 3, continuous version. So, yeah, we have passage 3 this time. It's called Plant Thermometer Triggers Springtime Growth by Measuring Nighttime Heat. A photoreceptor molecule in plant cells. I don't think it's really necessary to read anything here. Photoreceptor molecule. I think it's something that is related to plants and biology. So yeah. Um, Now we have questions. True, false, negative questions. Cambridge scientists discovery of the thermometer molecule caused surprise among other scientists. The targets for agricultural production by 2050 could be missed. Wheat and rice suffer from a rise in temperatures. It may be possible to develop crops that require less water. Develop crops that require less water. These questions they come in order. Plants grow faster in sunlight than in shade. So sunlight than in shade. This is a comparative. They are contrasting. Uh, phytochromes phytochromes change their state at the same speed at the same speed day and night. So they change same speed day and night. Mention of specialists who can make use of research findings. These questions, matching features, they tend to be pretty much easy sometimes. When you look at the question number 33, for example, mention of specialists, like you have to understand. You can automatically understand the logic behind it. Specialist means that you will find some names of professionals or experts of different fields. A reference to a potential benefit from the research findings. Potential benefit of the research findings. So that means scientists found something from the research, and in which they can benefit from it. Scientific support for a traditional saying. Reference to people traditionally making plans based on plant behavior. Making plans. Right. A reference to where the research has been reported. There we go. And we have daffodils are likely to flower early in response to something. If ash trees come into leaf before oak trees, the weather in something will probably be wet. Okay. Right. There's nothing to highlight here. Research was carried out using a particular species of. You can already see that the species is going to be some sort of a plant. All right, an international team of scientists led by University of Cambridge has discovered that the thermometer molecule in plants enables them to develop according to seasonal temperature. Um, According to seasonal temperature changes, researchers have revealed that molecules called phytochromes are used by plants to detect light during the day. Actually, their function in darkness to become cellular temperature gauges that measure the heat of the night. The new findings published in the journal Science show that phytochromes control genetic switches in response to temperatures as well as light to dictate plant development. So published in the journal Science is talking about reference to where the research has been reported. Yep. So I'm gonna take that. All right. We got the first answer. It's gonna be A. All right. Let's take that. And question number 37, I'm just going to highlight this part as well. I'm going to give this a number 37. As you can see, published in the journal Science means where the research has been reported. It was reported in the journal called Science. Now, at night, these molecules change states, and the pace at which they change is directly proportional to temperature, said scientists. So compare phytochromes to mercury in a thermometer. The warmer it is, the faster the molecular change, stimulating plant growth. Okay, farmers and gardeners have known for hundreds of years how responsive. Do we find anything from here? The Cambridge scientists discovered the thermometer molecules among other scientists. We don't know if it caused any surprise among other scientists, so the answer is going to be not given here. over here you can see that Cambridge has discovered thermometer, but there's nothing about other scientists. Now, farmers and gardeners have known for hundreds of years how responsive plants are to temperature. Warm winters cause many trees and flowers to bud early, something humans have long used to predict weather and harvest times for the upcoming year. So, to predict the weather and harvest times for the upcoming year means so the latest research pinpoints for the first time in a molecular mechanism in plants that reacts to temperature, often triggering the buds of spring we long to see at the end of winter. So here, it's making plants based on plant behavior. It means because uh, here's the warm winters cause many trees and flowers to bud early, which means, and this was a sign for humans to predict weather and to plan harvest time for the next year, which is upcoming year. So the answer is going to be this one, question 36. All right, let me put that normally over here. So C, we have we have answer number C. We have C over here. So it's going to be 36. 36, there we go. Now, moreover, with weather and temperatures set to become ever more unpredictable due to climate change, researchers say the discovery that this light sensing molecule also functions as the internal thermometer, and plant cells could help us breed tougher crops. It is estimated that agricultural yields will need to double by 2050. We already found this part, but climate change is a major threat to achieving this. There we go. We found the answer for question 28. I'm gonna take that. Give this 28. All right. And the answer is going to be here as true. There we go. Now, so crops such as wheat and rice are sensitive to high temperatures. Key crops are sensitive to this one. Wheat and rice suffer from a rise in temperatures. There we go. We found another answer, which is another true for us. We found two answers. It's from one paragraph, right after another, one after the other. So we're gonna give this a question 29. There you go. All right. It may be possible to develop crops. Thermal stress reduces crop yields by around 10% of every 1 degree increases in temperature, says lead researcher Dr. Philip Wiggy from Cambridge Sainsbury Laboratory. Discovering that molecules that allow plants to sense temperature has the potential to accelerate the breeding of crops resilient to thermal stress and climate change. Potential benefit of the research findings. Benefit is that the potential to accelerate the crops resilient to thermal stress, and research finds that discovering the molecules. This whole sentence is the answer for question 33. I'm sorry, not 33, but 34. Potential benefit of the research findings. Discovering the molecules. So they find molecules. So it's saying that discovering the molecules that allow plants to sense temperature has the potential to accelerate the breeding of crops. So which means that according to the research, they found a molecule that allows plants to feel the temperature of, be it sun or the moon. I'm not sure. It helps to speed up the breeding the breeding process of crops that are vulnerable to thermal stress and climate change. So the answer for 34 comes this part. There we go, 34, and I'm gonna give this a 34 over here. It's gonna be D. There you go. Now, in their active state, so a scientific support for traditional saying. I'm not sure here. It may be possible plants grow faster in sunlight than shade. It may be possible that to develop crops. We do not know we do not know if crops require less water. That's first of all, and second of all, we do not know that if that's possible to breed crops, to develop crops. Here is just saying the discovery of molecules and stuff like that, but it's not saying anything that it's they're capable of developing crops with less water, which means the answer is going to be not given. There you go. Now, in their active states, phytochrome molecules bind themselves to DNA to restrict plant growth. So, plant growth over here. During the day, sunlight activates the molecules, slowing down the growth. So here it is saying that plants grow faster in sunlight than in shade. Phytochromes change their state. All right. If a plant finds itself in shade, phytochromes are quickly inactivated, enabling it to grow faster than in the sunlight. So during the day, sunlight activates the molecules, slowing down the process. Here is saying plants grow faster in sunlight than in shade. Here is saying the opposite. During the day, during the day the growth slows down, but under the shade they are quickly inactivated. But phytochromes are quickly inactivated, which helps them to grow faster than in sunlight. So, which is going to be false. All right. Oh, whoops! It's not true. False. Grow faster in sunlight. Oh yeah, of course it's false. I guess so. I'm not sure. Hold on. Plants grow faster in sunlight than in shade. Grow faster in sunlight. So during the day, sunlight activates the sun, slowing down growth. Yeah, of course, false. Now, phytochromes change their state at the same speed of day. So this is how plants compete to escape each other's shade. Light-driven changes to phytochrome activity occurs very fast, less than a second. At night, however, it's a different story. Instead of a rapid deactivation following sundown, the molecules gradually change from their active to inactive state. So gradually change. Here it is saying it's a very fast, less than a second. So there are two things. So the answer is going to be false here as well. All right. It's going to be false. All right, there we go. Did we miss anything? I think we did not miss anything. We are left with daffodils, ash trees. Okay. The lower the temperature, the slower the rate at which phytochromes revert to inactivity. So the molecules spend more time in their active growth suppressing state. This is why plants are slower to grow in winter. Warmer temperatures accelerate darker reversion, so that the phytochromes rapidly reach an inactive state and detach themselves from the plant's DNA, allowing genes to be expressed and plant growth to resume. Okay, we don't. I cannot find anything about specialists here. All right. Some plants mainly use mainly use day length as an indicator of the reason. Other species such as daffodils have considerable temperature sensitivity and can lower months in advance during a warm winter. So in advance, here the word we found the first answer. I mean the first answer for sentence completion. So here the answer is going to be warm winter. You can write winter, or you can just write warm winter as well, because it allows you to write it allows you to write more than two words, no more than two words. There you go. You can see no more than two words. So yeah, it's pretty possible, pretty much possible. So here I want to give this a number again. It's going to be 38, right? So there you go. Now, in fact, the discovery of the dual role of phytochromes provide the science behind a well-known rhyme. So there we go. The discovery of the dual role phytochromes provide the science behind a well-known rhyme long used to predict the coming season. Oak before ash, we'll have a plash. Ash before oak, we're in for a soak. There we go. We found another answer as well. Traditional saying, right? It is traditional saying, some sort of rhyming. It's some sort of it's a really it's like a humorous way, humorous way to say something. So it's going to be 35. So the reason for that 35, let me first actually highlight it before I forget, because I have a very good characteristic. I mean, I have a very good character of highlighting it incorrectly. A scientific support for traditional sayings, it's going to be G here. All right, now navigate it closely here. Provides the science behind it. So, dual role of Pythagoras provide the science behind a well-known rhyme. Provides the science means scientific support. Wiki explains oak trees rely much on temperature, likely using Pythagoras as thermometers to dictate development, whereas ash trees rely on measuring day length to determine their seasonal timing, right? A warmer spring and consequently a higher likeliness of a hot summer will result in oak leafing before ash. So okay, we found we are almost there. A cold spring will see the opposite, as the British know only too well. A cold summer is likely to be a rain-soaked one. Rain-soaked one here is a wet. If ash trees come into leaf before oak trees, so here is that a warmer spring and consequently higher likeliness of a hot summer will result in oak leafing before ash. So here it says it's leaf. So it's like here leaf before oak trees. Ash come into leaf before oak trees. Here it says that oak leafing before ash. So, however, the cold spring will see the opposite. As in the Britain, a cold summer is likely to be a rain-soaked one. Rain-soaked one was me. Likely is probably, and likely is probably. So I can just write that down here. This probability words like probably is known as, let me just put it over here. Probably is known as likely. And then we have be wet is equals rain soaked one. There we go. Pretty easy. So the answer here is going to be summer, right? So weather in summer. Of course, you need collocation. You need collocation, logic, and grammar. Research was carried out using a particular species of something. Okay. Research was carried out using particular species of something. Okay, we don't know that. The new findings are the culmination of 12 years of research involving scientists from Germany, Argentina, and the US, as well as the Cambridge team. There we go. We found the answer here as well. So here I will give this a number. I will give this a number 39. 39, which is summer. 38 we already did. Now we will give this another one. This one is going to be question 40, I guess. No, I'm sorry, that's not 40, but that's 33. And most probably that's 33, and most probably it's going to be 40 as well. Most probably it's going to be 40 as well. Let me actually delete that for now, because we might have missed it. 33 is going to be H. Specialists or scientists. I'm gonna give that an H. So research was carried out. The work was done. So there you go. The work was done in a model system using a mustard plant. Mustard plant is a particular species of a plant. So there we go. So mustard plant. If you want, you can write mustard itself, or you can just write mustard plant. Usually, but you cannot say species of plant. Okay, so you have that, but there's an adjective as well. Mustard plant. What kind of a plant? It's mustard. So yeah, there we go, guys. We finished passage 3, test number 3. Yeah, if you have any questions, if you feel that there was something that I could not explain thoroughly or maybe clearly, make sure to comment that below. Let me actually give this the number as well. It's going to be question number 40, as I said. 40. Give this like that. So yeah, Again, thank you very much for watching. Thank you for the support. If you have any questions, once again, I repeat, make sure to comment down below. And if you haven't subscribed, make sure to subscribe as well. And I will see you on the next episode, guys. For now, bye bye.